So this is question 21 in chapter 13, and it reads, 3 objects of equal mass are located at 3 corners of a square of edge length L as shown in the figure. Find the gravitational field at the 4th corner due to these objects. So to do so, you're going to want to find acceleration. The gravitational field is going to be in forms of acceleration. So let's start with the formula we know, G m1 m2 over r squared. R squared is equal to F. But we also know that's equal to ma or mg because g is a form of acceleration. If you compare these two, one of these is going to be the mass of the objects. The other one is going to be the same as here. So we cross one out, and you're stuck with g of m, which we did replace m1 with the m here, over r squared, which is technically, well, from here to here, it's going to be l squared. And that's going to equal to g from this point. Except there is a direction because g is a vector. This is going to technically be in that direction for this guy here. Similarly for here, same formula, you go through the same process. So what happens is then you end up with this. That's this guy. So 1 is here, 2 is here. Now 3 is slightly different because instead of just going like this, there's actually a vector force going this way. So the force part is the same, but the way it's distributed among the x and y components is different. So for part 3, what happens is gm over l squared, except there's cosine of 45 degrees because it is a square. When you divide it and it goes straight here, this will give you a 45-degree angle. So it's cosine 45 for the I plus sine 45 for the j. That will even out to gm over l squared root 2I plus root 2j. Now we are very close. We have just one more step left, and it is to combine all of these forces. So now what we get, root 2 over 2. Cosine of 45 is root 2 over 2. So then we're going to add all of these together, 1, 2, and 3, and do mind the components. So you end up with Can you see what's happening? Oh, I'm sorry. So that's what's happening. I plus, and then I'm going to separate this part into the x component first. Plus. Now this is really ugly. You can condense it and do something a bit simpler. Dang it, I forgot the distributive property here. Gm over L squared. There. That should solve that. And then Gm over L squared, 1 plus root 2 over 2j. And these are the two parts of your vector. Basically, it's your vector components to find the gravitational field. If you want this in one number and in terms of the angle, you can square this, sum it up, and then square root it, just like you would for any other vector. And it should technically get you the same answer, just in different form. Okay, and that's question 21 in chapter 13.